Well, hello. We'll do some Algebra 2 here. Systems of linear equations. Okay, so let's talk about what a system of equations actually is. So basically, to get going, a system of equations is two or more equations. Okay, we're going to stick with two for right now, but quickly we will get to three, in which solutions satisfy all equations. Okay, so no more just solving for one variable. You're going to be solving for two or more. Okay, so we've seen one method of the graphing method, right, where you graph two linear equations, slopes and y-intercepts, and we look for their intersection, and that tells you that's actually finding the x and y value that solves the system. There are some other methods using algebra, which are sometimes a lot quicker. Sometimes graphing can be a mess, right? You might not have graph paper, or just the numbers might not graph nicely. So think about, for example, let's say we have an equation x plus y equals 5, right? So if you think about x plus y equals 5, there's a lot of answers to that, right? I mean, x could be 1, y could be 4, x could be 2, y could be 3, and so on. I mean, there's actually an infinite number of answers there. Because if we graphed that thing, we would subtract x from both sides, and you would get y equals negative x plus 5. So it would be a line, y-intercept of 5, the slope would be negative 1, that kind of thing. And that thing goes through an infinite number of points because it goes forever and ever. So when there are two variables, okay, you can't just have one equation. You're not going to get a single solution, at least. I mean, you can get an infinite number of solutions. Okay, but once we add this second equation to the mix, okay, let's say that that's equation 2, but these together form a single system, right? It's like one problem. Now we can lock in an answer, right? If x plus y equals 5 and x has to equal y, okay, some of you guys probably can tell x and y must both equal 2.5. Okay, because those are the only numbers that add up to 5 and the x value equals the y value. Okay, and if you were to graph those, that would be the coordinates of the intersection. It'd be 2.5, 2.5. But anyways, let's get into some examples, okay? But I just wanted to talk about what a system is. So it's basically like seeing two problems, two equations or more, and you need to find solutions that satisfy each of them. Okay, so I'm jumping into the text here. There's a few examples. This is page 33. Let's just walk through a couple problems. Let's do some problems. Let's start up here. So we have x equals 25 minus 3y. And then also 4x plus 5y equals 9, okay? And I'm just going to number the equations, equation 1 and equation 2, but you can remember they form a single problem, a single system, okay? This one is set up for, it's set up perfectly for one of the methods that's called substitution, okay? We're going to learn two methods to do these algebraically, substitution and then elimination. And those go along with the graphing method that we saw previously. But what you want to do with substitution, if you look at equation 1, right, it is already solved. Like, it's telling you what x equals. Okay, you don't have to do any work. It's telling you what x equals. So what we're going to do is we're going to take that expression, that 25 minus 3y, and we are going to, the name of the method is substitution, right? We are going to substitute in 25 minus 3y in for x there. Okay, so we're going to get this new equation. I'm just going to rewrite equation 2, which says 4 times, now I'm going to put in parentheses what x actually is, equal to 25 minus 3y plus 5y equals 9. Okay, and now what we just did, I'll just number this, we created ourselves a new equation, number 3, and if you look at equation 3, it doesn't have two variables in it, it only has y's in it. Okay, and there's more than one y, but it's just y's. It has only y's in it, so we can solve this thing for y algebraically. So let's distribute the 4 out. Okay, 4 times 25 is 100. 4 times the minus 3y is minus 12y. Okay, we'll rewrite the rest of it. Plus 5y equals 9. All right, and let's keep going on this. So we have 100. If if we combined minus 12y plus 5y, we're still left with minus 7y's equals 9. Okay, now we want to get y by itself, right? So we're going to solve for one variable first. Okay, so negative 7y will equal a negative 91. Okay, and if we divide both sides by negative 7, I'm going to get y equals, it's a negative divided by a negative, so I just divided in the calculator. Y is going to equal positive 13. Okay, so we got y. Now remember, this was a system. There are x's and y's in there, right? So we still need to get x. So what I would do now is plug this in to equation 1. Okay, because now that we know y, equation 1, remember, said from the top up here, said that x equals 25 minus 3 times whatever y is. And we just found out what y is. Okay, so if we do 25 minus 3 times 13, that should get us negative 14. Okay, because the 3 times 13 is 39, right? So 25 minus 39, that's where I got the negative 14 from. We know x now, we found y. We have solved the system using substitution. Alright, so let's walk through a second example where we're going to be doing setting up a word problem and then doing the same method to solve it. Alright, so example 2 here. Let's see part D there. Eli invested a total of $2,000 in 2 stocks. One stock cost $18.50 per share and the other cost $10.40 per share. And Eli bought a total of 130 shares. So let's write and solve a system of equations to find out how many shares of each stock Eli bought. Okay, and this is a great like SAT style problem where it's a word problem, but it's a system of equations setup. So let's think and kind of take a peek at the end here. What is it we're trying to find? Right? We want to write and solve the system to find how many shares of each stock he bought. So sometimes, obviously in this problem, they didn't just write equations for you. So we need to start out by defining the variables. So let's say let x equal the number of shares. And there was two types, right? There was an $18.50 share. So x will be the number of $18.50 shares. Okay, we're going to start out by defining variables. And y will equal the number of the other one, which was the $10.40 shares. Okay, and this step's going to be real helpful because it's going to keep things organized. When we get answers and when we get to the end and say x equals whatever, we already stated what x is, like what it means, right? So we kind of interpreted our answer, which is a big deal here. Okay, so let's see if we can write some equations and see what we got. Okay, so again, keep in mind, x and y are the number of shares. So when I see this statement right here, Eli bought a total of 130 shares, I know some of those were the $18.50 and some of those were the $10.40, but the total combined, okay, the x plus y is 130, right? That's the number of shares. Okay, our next equation will be the one that deals with the amount. Okay, the total amount he spent was $2,000. Okay, the $18.50 share, he bought X of those. Okay, so $18.50 times X, because that's how many of those he bought, right, plus 10.40 times Y, that needs to equal the total amount of money spent, which was $2,000. Okay, so if you take a look, the blue equation, and keep these straight, these can be confusing. The blue equation is just about number of shares, right, and the total was 130. The green equation is about the dollar amounts. Okay, the total dollar amount was 2,000, and then it was $18.50 for each, plus $10.40 for each of those. Okay, now we have ourselves a system of equations. Okay, and we can solve this. We're going to use the substitution method one more time. So to do that on this one, it's not like the previous one where one of the equations is already solved. Okay, so we need to do that ourselves, and it's probably going to be easiest to solve the top one either for x or for y. Okay, so it doesn't matter which one you solve for, right? So I'm just going to solve for x. Okay, so if I solve that first equation for x, I would just subtract y from both sides. So I will get a new equation that says x equals 130 minus y. Okay, and I'm just going to name that equation 3 in case we refer back to it later. Okay, that equation, it just came from equation 1. Okay, so we can use it. So let's use it. Okay, let's substitute, and I'll just try and kind of write what I'm doing here. I'm going to substitute equation 3 into equation 2. Okay, meaning where this x is right here, I'm going to plug in this stuff. Okay, so let's do that. So we have 18.50. Now instead of x in parentheses, I'm going to put something that equals x, right, which is 130 minus y. And I'm going to write the rest of equation 2 still. Okay, so we can keep going on that now. I'm going to use my calculator here just to distribute. So the 18.50 times 130 is 2405. So I'm distributing the 1850 right now, right? So 2405. Okay, and I'm going to distribute the 1850 times that minus y, so minus 0.1850y. Then we have plus 10.40y. And this still needs to equal 2,000. Okay, now we can combine the like terms. Negative 18.50y plus 10.40y. Okay, those will combine. So we have the 2405. Okay, all I'm doing here is combining these two things to become minus 8.10y equals 2,000. Okay, then we're just going to solve this for y. Okay, just go through some normal algebraic steps. Solve for y. I'll subtract the 2405 from both sides and be left with negative 8.10y equals negative 405. And when I take that negative 405, dividing it by negative 8.1, I'm getting y equals 50. Okay, so y equals 50. Okay, and remember again, we defined y earlier. Y was the number of $10.40 shares. So since we did this step up here, it's clear to your reader or whoever's question you're answering what the y equals 50 means, right? That's telling you how many shares. Okay, now what's going to be our easiest way to get x? We are going to use, I'm going to plug that into equation 3, okay, which said x equals 130 minus y. We know that y is 50, so x will just equal 80. Okay, and again, we defined x at the very beginning, so I know what x is. Now, if you do this problem and you don't tell me, okay, if you don't tell me what x and y are up at the top, and you just tell me x equals something, y equals something, I can't give full credit because you're not telling me which one's which. Okay, so either write a conclusion sentence or have them defined from the beginning, which is what I recommend because it helps when you set up the equations anyways. Okay, and there's one other method that sometimes is useful called elimination. Let me just make up a quick problem here that you're going to see why the elimination method might be quicker on certain problems. Okay, let's just say, for example, we knew, I'm just going to make one up here, 2x plus 5y equals 10, and then x minus 5y equals 1, something like that, okay? And let's just see if this will work or not. I just made it up. So a system, right? Equation 1, equation 2. So if you were using substitution, the easiest bet would probably be to start with equation 2 and solve it for x. Okay, and I know that's going to be the quickest because there's no coefficient in front of that x. There's nothing we would have to divide by. We could just simply add 5y. Okay, but when things are written this way in standard form, meaning it's something x plus something y equals some number. Okay, it's called standard form. Things are lined up, right? Both equations are written that way. What you can do is, okay, before we do it, this method is sometimes known as addition, because what you can do is you can add these two equations together, and this setup of this one's perfect for this method, because take a look at what happens when I add these straight down. The 2x plus x becomes 3x. The positive 5y and the minus 5y actually eliminate, right? And the 10 and the 1, of course, is 11. So you would get a new equation 3, okay, which is solvable. Would divide both sides by 3. It's going to be a little messy because it's a fraction. Okay, but you could get the answer for x right away, and then you would have to either substitute that back into equation 1 or 2 to get y. Okay, so it'd be a little messy because of the fraction, but again, just if I saw the equation written this way, elimination would be the method I would jump to immediately. Okay, so I'm not going to do those steps. We'll do it on the next one. Okay. All right, let's do one more though, where we go through the whole process. Let's write our own equations and use elimination, because sometimes there are a little bit more steps needed. You know, look at the last one. The thing that made elimination work so nicely was that we had this kind of situation, right? A plus 5y in one equation and a minus 5y, so those just straight up eliminated. Okay, so let's take a look at this last one here. So a karate school offers a package of 12 group lessons and 2 private lessons for $110. It also offers a package of 10 group lessons and 3 private lessons for $125. Let's write and solve a system of equations to find the cost of a single group lesson and a single private lesson. Okay, so like the last word problem, let's define our variables. We need in the end to know the cost of a single group and a single private. So let's define variables. I'm going to use G. Okay, you can use X and Y or whatever all the time, but I'm just going to use the first letters just to help me keep this organized. And P will equal the price of a private lesson. Okay, and let's write our two equations, okay? So one from the first sentence, right? We know that 12 group lessons and 2 private lessons need to add up to $110. So our first equation could be it's $12 times the number of group lessons, G, plus 2 times the price of a private lesson. I think I misspoke in the first one. G is the price per group lesson. So it's 12 times the price plus 2 times P, which is the price per private lesson. That total needed to be $110. And then equation 2 from the next piece of information, right? 10 group lessons plus 3 private lessons. 10 group plus 3 private is $125. Okay, and we have ourselves a nice little system of equations. All right, and we're going to do it with elimination. Okay, substitution would do it too. Okay, and it just depends. The way the problems are written, sometimes it's going to be much quicker to do one method. Sometimes it might not matter. They might both be about the same. This one, looking at it, they might both kind of be about the same. You know, if you were going to do substitution, you would have to subtract one of the variables over, but then also divide, right? Because each of them has a coefficient other than 1. All right, but elimination's not going to be perfect either. We don't have that here. Okay, so what you have to do sometimes is multiply the equations to make that happen. Okay, so I'm looking at these, and sometimes there's a way where you can just multiply one equation. Okay, like for example, just bear with me here. Imagine if this, instead of being 3p, was 4p. If that was 4p, I could just multiply the first equation by -2 to make the p in that be -4p. And then we could eliminate. But, unfortunately, this is not 4p, it's 3p. So one thing we can do is one thing we're going to have to do. We're going to have to multiply both equations by something. Okay, so let's do that, and let's just get a plan together. I'm going to try to eliminate the p just because the numbers are smaller, and I'm looking, one of them has a coefficient of 2p, and the other one has a 3 in front of the p, so I'm going to try to get them to be 6 and negative 6. Okay, that's like the least common multiple of 2 and 3, right? That's just going to be the easiest way to do this. So what I'm going to do, I'm going to multiply this first equation. Let's say we multiply it by 3. Okay, as long as we do the entire equation, we can do that. So let's distribute a 3 to everything. So the 12g becomes 36g. The 2p becomes 6p. Don't forget to multiply the 110. That's one big step I see missed a lot of times, right? We need to distribute to all the terms, including the 110. Okay, so there's a new equation. Now what would we need to multiply this one by? Okay, I want this 3p to become negative 6p so that it will get eliminated. So I would need to multiply by negative 2. Okay, so negative 20g minus 6p. The 125 times negative 2 should be negative 250. Okay, now we should have something set up nicely where we can do our little addition, okay, which is going to eliminate. Notice what's happening with the p's there, right? They're going to eliminate, which is what we wanted. So when we add these together, okay, 36g and negative 20g, we get 16g. Okay, the p's eliminate, which is what we needed. And then 330 and minus 250 is 80. Okay, we divide both sides by 16. And we should get an answer. I believe that's 5. Okay, so each group lesson we just found is $5. And now here's where we got to do that final step. We need to substitute back in. Oops, this is not letting me move everything for some reason. Let's see if I can just move. Oh, I'll have to do it down here. To get, what do we need now? P. Let's plug it back into the original equation. Let's just plug it into the first one, I guess. So equation 1, okay, going into this one, said that 12 times g, right, we just found out g is 5, plus 2p needs to equal 110. Okay, we can solve that now for p. 12 times 5 is 60. Okay, 60 plus 2p equals 110. I will subtract 60 on both sides. So 2p is going to equal 50. And dividing by 2, p ends up equaling 25. Okay, so we found p. We had found g earlier. We have solved the system. We cracked the code. Right? Feels good, huh? Kind of like solving a mystery. So again, those are very, very common on the SAT. Okay, systems of equations. A lot of times they'll give you the equations, but a lot of times too, it's just like this. It's a word problem. You have to write it out and solve it yourself. So hopefully that helps. You can use substitution or elimination. Or again, if something's set up nicely for graphing, if it looks like it's slope-intercept form and you have some graph paper there, that method works as well. All of those methods solve systems of equations. All right, talk to you later.